All right, let's talk about converting rectangular equations into polar form. Now, you should know from pre-cal last year the polar conversion formulas, where x is r cosine theta and y is r sine theta. So when you're converting rectangular equations into polar form, you literally are just plugging those things in for x and y. So A and B are both kind of like really easy. For A, you just plug in the r sine theta and r cosine theta, literally. For B, you plug in r cosine theta for B, and you want to get the r by itself, so you divide both sides by cosine. So it'd be 10 over cosine theta, or 10 secant theta. But I want to talk about C and D, because they're a little more interesting and have a little more work involved. So for C, x squared plus y squared equals 4. So x is r cosine theta, y is r sine theta. Now, each of those things is being squared, right? So this is r squared cosine squared theta, r squared sine squared theta. And now we want to get r by itself. In polar coordinates, r is the dependent and theta is the independent. So typically we like to get the dependent variable by itself if it's possible. So what I'm going to do is I'm going to pull out an r squared, and then sine squared plus cosine squared, that's a Pythagorean identity you should know. That equals 1. So this is r squared equals 4. So you could write that as r equals 2. So essentially this is going to be a graph where the distance to the origin is always 2. In other words, it's a circle centered at the origin of radius 2, which, if you remember stuff from earlier classes, is exactly what that is. Now, part D. X squared minus y squared equals 4x. So again, we're going to do the same thing. We're going to do a substitution. We're going to multiply these things out. We're going to factor out an r squared. And then we're going to use an identity, but this time cosine squared minus sine squared isn't 1, it's cosine 2 theta. I didn't really need that parenthesis, but that's okay. Now, to simplify this more fully, whatever, I'm going to divide both sides by r. For some reason there we go. So it should be r times cosine 2 theta equals 4 cosine theta. Now typically the answer key on this doesn't do it. We would want to get the r by itself. So it'd be 4 cosine theta over cosine 2 theta, but it's not a big deal either way. So we'll leave it like this since that's what the answer key has.